And now I'm going to talk about the fuzzy inference system. In total, we have 3 fuzzy inference systems, and then that is this section. I'm going to put everything together to form this fuzzy inference system. So the first one, so the 3 common fuzzy inference system, that is, we have the Mamdani fuzzy inference system. That is the one I mentioned before. And then another one that we call this is the Tsukumoto fuzzy inference system. And sometimes we call this is the TSK fuzzy model. And another one that would be the Tsukumoto fuzzy inference system. If you look at the difference, and then when we talk about the Mamdani fuzzy inference system, in the if part, they are all the same. For the consequent part, that means in Mamdani type fuzzy inference system, we allow a general membership function. That means that we can use any shape. And for Tsukumoto fuzzy inference system, the consequent membership function, that is a mathematical function. That means we are going to have a function subject to different input values, and then the membership function will change. Yeah, and the Tsukumoto fuzzy inference system, that is, in order to simplify the implementation, the membership function, that is monotonic increasing or decreasing. I'm going to show you the details later on. Now, this is the Mamdani fuzzy inference system. Now, right here, you can just find out that all these rules, the if part, we have x1, x2, x3, so and so, they are the input variables, and then a11, a12, they are some fuzzy set, say small, large, or something like that. And then y is b1, b2, so and so. So this is a multi-input. Yeah, so multi-input x1, x2, so and so, and then so we have y as the output, multi-input, single output system. Yeah, so this is the fuzzy inference system. And now B, that is, it could be any kind of membership function. We mentioned before, we can have the S shape, we can have the Z shape, we can have Z shape, S shape, trapezoid, triangle, whatever. Yeah. And now, actually, we know how to find the output using the input and the fuzzy inference engine, as well as the knowledge base, combining with the diversification process. And then now we are going to talk about the Tsukumoto fuzzy inference system. The if part, as I mentioned before, they are all the same. The only difference is that now the output membership function, that is just a function. This is function 1 in terms of x1, x2. They are the input of the if then part. Yeah, so all of them in the then part, we have an individual function from f1, f2 up to fr. Yeah, and now this is some details about how do we form the output y. That is the way we do the diversification. So if you're going to look in the details about that, that is a weighted average. We call this is the weighted average because y, that is y1 as y equals w1 times f1. f1, that is this function. w1, that is after rule evaluation, that is the contribution made by rule 1, and rule 2 we have w2, and then up to rule r, wr. So the numerator, that is w1 times f1, and then w2 times f2. Yeah, so if you do not want to look at these x1, x2, that is to simplify that w2 times f2 plus up to wr times fr, and then to the denominator, that is just the sum of all the membership weight. Yeah, okay. In compact form, we can write using the summation sign, and then when we talk about wi, we can use the product, or we can use the mean if we are going to deal with the AND operator. Yeah, okay. This is a simple example. We have 2 roots, and then one input x. So this system, that is x as the input, general fuzzy inference system has one output. Now I assume that A1, this is the membership function right here, A1, and then so B1, that is this is the two input single output system XY. Yeah, so this is for right here, that is for X. Yeah, so this is A1, the membership function, A2 right here, and B1, this is the membership function, B2, that is the membership function right here. So this is for rule 1, this is for rule 2. Now look that instead of using membership function in Mamdani type fuzzy inference system, we are going to have a function. This is f1 in terms of x and y. This r1 is a constant. Yeah, so we have to determine that. Yeah, so P1, Q1, R1, they are constant. So that means F1 is a polynomial. Yeah, Z2, this one, this bit, that is F2 in terms of X and Y. Again, P, Q, P2, Q2, R2, they are some constants we are going to determine. So take a look at this figure right here, because we consider n, so we can do minimum or product. So that means if we are going to do product, W1 will be, yeah, so W1 or Wi, that would be the minimum between these two values. Yeah, if we are going to do product, that is the product of these two values will be the W1. It depends on how you define the fuzzy and operator. So once we find W1, W2, if we change the value of input of X and Y, these two values will change, and then W1 will change, as well as Z1 will change according to the value of X and Y. So Z, that is weighted sum, W1 times Z1, that is this value, plus W2, this value, times Z2, that is the numerator, the denominator, that is W1 plus W2, the sum of these two guys. Yeah. Okay, so if we have more roots, we are going to extend that to W1, W2, W3, W4, so and so. Yeah. Okay. Now, another example. This is two input X and Y, and then Z, that is the output. Yeah. So we are going to have two input with the membership function for X, that is small and large. So I put it right here. This is for X. So this is for X. So this is small, this is large. And then for Y, we have another membership function, small and large. This is small, this is large for Y. So again, I have to emphasize that this small, that is for X. This small, that is for Y. So although we use the same fuzzy terms, small, they refer to different things. So when we talk about X is small, we are going to use this membership function. If we are talking about Y is small, we are going to use this membership function. Don't be confused with that. Yeah. Now, this is the output membership function. This is, say, this is F1, X1, Y, X and Y. Yeah, so you can just find out from here, Z, that is W1 times this F, and then W2, that is given by this root times this polynomial, and this is for W3, and then so we have this bit, this is W4, we have W4, and then so we have the function here. So if you consider all the values of X and Y in the range of -5 to 5 for X, -5 or 5 to for Y, and then put it in a 3D plot, this is the X, this is Y, this is the Y axis, that is Z, and you will just find out that although this is a linear, each function right here, it is linear, but W1 to W4, they are non-linear. So the surface, that is non-linear. Okay, so W1 to 4, it depends on whether you use mint for AND or you are going to use the product term for AND. Yeah, so when you choose different definition for and, it will change the shape as well. Yeah, so that means when we use the fuzzy inference system, we are able to turn each rule may be the output, the consequence, that is linear, but when we combine them together, it will become nonlinear. Yeah, so we can use the fuzzy inference system to approximate any nonlinear function. Okay, now Tsukumoto fuzzy inference system. The if part, they are the same. That means we will use the same rule evaluation method. The only difference is that y, that is defined like this. So if you look at this form that is exactly the same as the Mamdani type fuzzy inference system. Yeah, but the only difference, that is, we only allow simple membership function, either monotonic increasing or monotonic decreasing functions. Okay, so this figure just we have two inputs as well, x, y, and z. Yeah, x, a1, a2 with fuzzy z right here, and then this is for 1, this is for rule 2, so a1, a2 plotted right here, b1, b2, and then there's c1, c2, c1, c2 right here. Again, how to deal with this and, that is the way how we obtain this w1. Anyway, when we get to this point, when we perform diversification to come up with the output of the y, we use the weighted sum approach as well. w1 times z1 plus w2 times z2, and then this denominator, that is w1 plus w2. And note that this w1, that is the value in the x-axis, the label, that is z. So when you change w1 according to the input x, because when you change x and y, these two values will change, and then w1 will change up and down, and then z1, that is corresponding to the intercept, the x value in this interception point. So z1 will move as well, yeah, will change as well. So this one just give you a nonlinear function as well. Okay, now take a look at another example. This time we have single input x right here, and then single output y right here. Small, medium, large, and then I put it in one single figure, small, medium, and large. That means if you are going to put it rule by rule, so we will have small, medium, and large, and then y, this is rule 1, this is rule 2, rule 3, and then so when you follow this c1, it will be something like that, and then rule 2, c2, and then now c3, that will be something like this. Yeah, so for convenience, and then we put all the figures right here, we put all the membership functions in one figures, and then this is for small, medium, and large, and then this one, that is for c1, c2, c3, and then now after we have the rules, and then we perform diversification, that is mu small x times c1, that is something exactly the same as this is w1, because we only have one rule. Say when we have this value, and then so okay, so when we have this value as the output, this will be w1. This w1, actually this is this mu small x, yeah, so this is mu small x, so this is w1. So if we have two inputs, we need to pick one from here. So the same right here, w1 times c1, that means if we have a value here, and then we draw a horizontal line, cut across this point, look for the x value, look for the y value right here. This one I call c1x. This c1x will change according to this point. If you are going to move this point to the left, to the right, and then this point will go up and down, so this value c1x will change accordingly. Yeah, so this is for medium, and then so we have the medium value cut across with this membership function, and this is for rule free, so this is W2, this is W3, and then C1, C2, C3. Now this this figure that is showing about the C1x, this one that is C2x, C3x. That means when we change the value of x from -10 to 10, and then we just want to find out what value this C1 will give you. That means when you change this value from -10 to 10, and then we will have a lot of value cut across to C1, and then we look for the y value. We plot it right here, and then we come up with this line. For example, when we talk about -10, that means the input that is -10, that is this point. Draw a horizontal line. It goes into this point, and the x-axis, that would be this point, that is 2. So we put 2 right here. Now if x, that is at around -5, say here, and then so we come up with a point here, and then we look for the value right here. That may be something about 1. So -5, that is right here, that is about 1. Okay, so consider all the x value, and using the C1 we come up with this line. The same applies to C2 and C3. We just put them right here. Using this approach, using this equation, put all the lines together with the weight W1, W2, W3, we come up with the final output. When we input x into this fuzzy inference system, it will give you the y value. Say when we input x and as 0, and then output y will be 4. Okay. And now, once we know the final form, the y, the input-output relationship of the fuzzy inference system, and then how do we do the training? Yeah. So that means how do we combine this later inspired fuzzy inference system with the later inspired learning algorithm? Say, assume that we have 2 roots, and then this system, that is x and y as the input, and z, that is the output. So that means we can come up with a function for the inference system z, that is fi as a function with the input x and y. So now when we look at this function, and then it could be, for example, it could be in this form: w1 f1 x y plus w2 f x y divided by w1 plus w2. This is the Sugeno system. And now how do we combine that with, say, genetic algorithm? Now, for example, if we would like to do a curve fitting, so we have a number of points when x, okay, maybe we are going to have x and y, yeah, x and y, because this is 2 input system. So when we have an x and y value, we have this point, and then so we would like to corresponding to different x and y value, we have these points. So now that means we need to formulate the problem as an optimization problem. Assume that f1, we have 2 parameters, like p1 x plus p2 q2 y plus r1, and then f2, that is p2 x plus this one should be q1, and this one q2 y plus r2. f1 f2, that is these 2. So I just define that as a polynomial function. And now if we define the membership function, say this is like this, and then this is like that, this is like this, and then this is like that. So W1 is defined, and then we choose P1, P2, Q1, Q2, R1, R2 to be unknown. And now, because we want to do the curve fitting, so we can just simply fit in each point into this fuzzy inference system, so we can find the error. Yeah. Now, say this point, for example, this point that is x is 1, y that is 2, and z we expect that to be 3. Yeah, to be 3. So when we fit in 1 and 2 right here, and then the output we expect that to be 3, but now we have the first error, minus 3 square plus another point, maybe this point that is 2, 3, 4. 2 that is x, 3 that is y. We expect that the output to be 4, but before the training, or this function is not good enough, the output z may not be 4. So we are going to just sum up the error. Yeah, so we can have the sum of the square error. This z that is due to the point 1, 2, 3, and this z that is due to the second point 2, 3, 4. Okay, so after we find all the errors, and then our objective, the genetic algorithm, is just to find PQR, so that to minimize this cost. So for example, I just call this to be the cost. So our problem becomes minimize the cost, defined right here, and the chromosome, the structure, that would be P1, Q1, R1, P2, Q2, R2. Okay, so that means we use the genetic algorithm to find these 6 variables. They are the decision variables, so as to minimize the cost. And if we find a good solution, and then when we are able to approximate these points. Yeah. Okay. And now, just to repeat, just to summarize what I just mentioned, the first thing we are going to do using the fuzzy inference system for learning, that is, we need to understand what the problem it is. If it is a curve fitting problem, and then we are going to formulate the problem as a curve fitting problem and put it as a minimization problem, and then that is to define the cost function, fitness function, or objective function. And then we need to know about the structure of the fuzzy inference system, the lump of input, the lump of output, and then later on we are going to write down the mathematical equation right here, and then to figure out what would be the decision variables. Right here, we just assume that the polynomial constant, the coefficient of the polynomials, they are unknown. But actually, we can extend that to W1 and W2. So W1 and W2, they are the shape of the membership function. If we are going to also say these 2 points, they can be the decision variables. That means we can just ask the genetic algorithm to define the position of the membership function, and then we can add these variables into the chromosome, so that during the training we will change also the shape of the fuzzy inference system. Yeah, and then now the next point, that is, we should pick the right learning outcome for the training. For example, whether gradient descent approach can be applied, whether random walk can be applied, whether genetic algorithm can be applied. Maybe we try all of them just to choose the parameters given which give the best result. Yeah. Okay, so this is the way for us to combine this fuzzy inference system with the learning algorithm